Hello guys, welcome to Sad Decoder. In today's video, I'm gonna be doing a Python challenge about my most popular video E. And I discovered a new way, and that is 1 plus 1 over n. So by asking the user of a number, what's your number? Then I can just generate E, and we use this a little bit weird formula that works 1 plus 1 over the number that the user inputted to the number. So by running this, if I input 100, I get 2.70, which is, and the actual one is 2.718 or something. And if we do 10,000, 2.71814. But what if we want to do it as a fraction? Do you know how pi is 22 over 7, and this is not known, but the square root of 2 can be known as 17 over 12. It's an approximation. But how about e? No one talks about e, so we're gonna do e now. So 1 plus 1 over n is actually n plus 1 over n, and then to the n, and if that is to the n, then n plus 1 to the n divided by n to the n, so that works. So what we're gonna do is actually just separate this a bit. We're gonna put an f query here so that we can easily put fractions, and right here in the first number we're gonna just put the power of the number plus 1 to the number, and the second one is actually the power of the number to the number. Pretty basically that's it, and this is going to generate this extraordinary fraction. I'm not even gonna tell you about this, but these are insane fractions that actually work. We're gonna do the formula just to show you what these are equal to. 1 over the number to the number. So if I say 100, this whole thing is equal to 0.718, and that. But you want to go for small numbers because your PC is not gonna store that. Like, your terminal is not gonna store that whole thing. Give me the most random number in your mind. Probably minus 12. So we get this weird fraction that actually approximates it. And this is pretty basically it. But the actual challenge, there's another challenge, and I think I'm dividing this by 2 parts. I want to see the common divider of these two. But that is gonna be hard. So we need a top and bottom. So the top is this, and then the bottom is this. Bottom is the power of that and that, and now we're gonna need to do some here and there and there. So we need to we're gonna say if we need a for I in range, and what's the range? It's just the range of the number. We're gonna look through every single number, and we're gonna see if top modulus I starts as 0, so we need to start at 1, but we actually need to start at 2. So we start from 2 to plus 2. So I is now just 2, start at 2. Is equal to 0. And how do you do the AND formula? Is it AND? I think it's just right AND. Oh, there we go. And I'm gonna say bottom modulus I is 0. Then if this works, then set the top equal to the top divided by I, and set the bottom equal to the bottom divided by I. So I think this does little loop until it's go. If this works first try, I am genuinely gonna be surprised. We're gonna input a small number. We're gonna start with 9. No, 8. Oh, I need to print it actually, and this is another. Oh, it's just top and bottom. There we go, and let's run this. And we will say No, let's just say 8. Oh, this is a smaller number, is it? Is this a smaller number, guys? But is this even true? We're gonna say this and top divided by bottom. This is actually the same thing, and it's reduced, guys. It works, no way. As it's reduced though, and this runs for infinitely many times for I in the range of all these. Oh, but here it did it. But and then do nothing, and then look for the next I, and it does. So just do nothing, and then if it does, then do that. It works. It works, guys. So we're gonna do 3. 3 is 64 over 27. I mean, we need some big numbers now, huh? We're gonna do 504. Okay, maybe that is way too big. We're gonna try 96. Okay, this is way smaller. This ends with 1 and this ends with 6. This is actually promising. This divided by that is actually... So, the answer is, if you wanted a good approximation, use this. For a 2-digit though, I don't think there is. I don't think we'll find a good 2 digits. And this is hopefully gonna be our next challenge. Our next challenge is gonna be 2 digits over 2 digits. So, guys, I want to tell you one more thing before you leave. Please subscribe. I know this, it's free. It's completely free and it means a lot to me. Goodbye.